Welcome to my channel, Chemistry Class. Good morning, everyone. Welcome back to Chemistry Class. My dear student, on our last classes, we discussed Bohr atomic models and the concept of shells or energy levels. My dear student, today we will discuss a very interesting and important topic, which is energy of electron in orbit. My dear student, we all know electrons revolve around the nucleus and specific orbits. But have you ever wondered, does the electron have the same energy in every orbit? Uh, how is the energy of an electron related to Earth's position and an atom? But dear student, today's class will clear all these doubts. Now let's get started. Energy of electrons, basic concepts. Students, as per Bohr's model, electrons revolve in discrete orbits or shells, which are also called energy levels. Also, my dear student, key points: each orbit has a fixed and a definite amount of energy. The orbit closest to the nucleus has the lowest energy. As the electrons move to outer orbits, as energy increases. This is why these orbits are also called energy levels. My dear student, also important note, the closer the electron is to the nucleus, the stronger the attraction, so it needs less energy. The further the electron is, the weaker the attraction and the higher its energy. So a conclusion is that energy of electron is quantized. It can only have specific fixed values and specific orbits, not in between. Now, explanation using Bohr models. But dear student, Bohr explained that electrons in an atom can only revolve in those orbits where the angular momentum is quantized. These orbits are also called stationary states because while in these orbits, electrons neither lose nor gain energy. But when an electron absorbs energy, it jumps to a higher energy level, excited state. Excited state. And an electron loses energy, it falls back to a lower energy level, releasing energy usually in the form of light or electromagnetic radiations. Now, my dear student, examples: an hydrogen atom first orbits n is equal to 1 lowest energy, second orbit n is equal to 2 higher energy, third orbit n is equal to 3 even higher energy. So an electron in the third orbit has more energy than the first orbit. Now, mathematical concept. Additionally, it is optional for the end class, but good or no. Though not required in depth for your levels, you should know that the energy of an electron in the nth orbit of a hydrogen atom can be given by En is equal to minus 13.6 electron volt divided by n square, where En is equal to energy of the electron in nth orbit, n is equal to orbit number like 1, 2, 3 and so on, and minus 13.6 electron volt is the energy of the first orbit. Is the energy of the first orbital. But dear student, this equation shows energy is negative, meaning the electron is bound to the nucleus. As n increases, energy becomes less negative, approaches zero. After energy becomes zero, electron is free, ionized. Now, important point to remember, my dear student, the first one is energy increases as we move away from the nucleus. Second one, energy level are quantized, fixed, and definite. Third one, electron absorbs energy to move to higher orbit, excited state. Fourth one is electron releases energy to move to lower orbit, ground state. Fifth one, in the ground state, electron has the lowest possible energy. My dear student, this is all about today's lectures. I hope you all understand. My dear student, if this lecture helped you, then don't forget to like the video, subscribe to the channels, and press the bell icons, and share it with your friends, and comment your question or any doubt below. Take care and see you in the next class. Thank you for listening.